It is often the small steps, not the giant leaps, that bring about the most lasting changes. Hi everyone, in this video we will go through 1-marker questions from limits and continuity. Now, first step, right, whenever we are looking at limits problems, we will have to, whatever limit value is given here, we need to substitute in the expression. That is the first step. And if you get 0 by 0 after substitution, then we will have to apply different methods. First step is to substitute. Now, you have x tends to 2. So, substitute 2. Wherever x is there, substitute 2. So, you will get 2. Instead of x, I have put 2. So, 2 square. And instead of x, again here I have put 2. So, now I substitute, I get 20. So, this is the limit value. Right? Here I have not got 0 by 0. I have directly got the value. Now, next problem. Evaluate limit for this particular expression. Now, again, first substitute this value 3 wherever x is there. So, what will happen if I substitute 3? I will get this particular expression. So, when I solve this, I will get minus 3 by 1, which is minus 3. So, this is also simple. Third problem. Evaluate limit x tends to minus 3 here. Okay, notice this. This is minus 3 and this is the expression. Now, here if I put x as minus 3, what's going to happen? If I put x as minus 3, I'll get like this. Minus 3 plus 3. So, what's going to happen here? Minus 3 plus 3 is going to be 0. And 3 cube is 27. Right? Minus 27 plus 27 is going to be 0. Now, I should not be getting 0 by 0. Right? Now, I'm getting here, I'm getting 0 by 0. So, that means I have to apply a different method. Direct substitution will not work out. So, what's the different method? Immediately we'll see if you can apply the limits theorem. What is the limits theorem? This is the limits theorem, right? This is the limits theorem. If you have expression of the form x to the power n minus a to the power n by x minus a, then you can write it as n into a to the power n minus 1. So, this is a very important limits theorem. For us to apply this theorem, this expression should be in this form. So, you should have x, a is any number, okay? A can be any number like 1, 2, 3, any number. N also can be anything, it's a power. And whatever you have, x and a, same thing should be there in the denominator, but without any power, right? This is the theorem. Now here, you have plus here, but we need minus, right? If you notice, x is there here, x is there here. Here 27 is there, here you have 3. So what you can do is, you can write this in the form of 3. What is 27? Can you write 27 as 3 to the power 3? 3 to the power 3 is 3 into 3 into 3, which is 27. So, instead of 27, I can write it as 3 to the power 3, right? So, now we have got it in this particular format. But there is one small problem. Here you have plus sign, but you need to have minus sign here. What do I do? This is the clue. This is the clue. I have x tends to minus 3 here. This itself is the clue. So, you put minus 3 here, right? You put minus 3 here. It doesn't change the equation. What is minus 3 into minus 3 into minus 3? What is minus 3 into minus 3 into minus 3? It's minus 27, right? So, and I'm putting minus here. This is going to be minus 27. Minus and minus is going to be plus. So, I'm not modifying the expression, right? I'm just writing it in a different way. Same expression, I'm writing it in a different way. Similarly here, I have x plus 3. I can write it as x minus 3, right? Minus and minus is plus. So, it's going to be x plus 3. Same thing, right? Now, once I write it in this format, it is same as this theorem format, right? So, I can apply the theorem. So, n into a to the power n minus 1. What is n here? This is n. The power is n, right? The power is n into number, not x. What is the number here? Minus 3, right? Number to the power, reduce the power minus 1. So, what is the power here? Power is 3, right? And what is the number? In place of a, what do we have? Minus 3. And you should decrement the power. 3 minus 1, you have to decrement it, right? So, I get 3 into minus 3 the whole square, and the answer is 27. Your minus into minus becomes plus, thereby the result is positive. Next one, evaluate limit this particular expression. Here, this is a very straightforward problem. Just substitute 1 in x, right? 1 square plus 6 into 1 plus 4. So what do you get? 1 plus 6 plus 4, 11. Right? That's all. Straightforward. Easy 1 marker. Next one. Again, here you have an expression. Substitute and see. First, substitute and see. If I put, instead of x, if I put 3, I'm putting 3 here instead of x. What do I get? 6. Okay. So this is the right answer. Only if I get this kind of a thing, 0 by 0, then I have to think as to if I should apply theorem or is there any other method. Next problem. You'll have to evaluate this limit. First of all, you need to substitute. If I substitute x with 1, it's going to become 1 cube minus 1 cube by 1 minus 1. It will become 0 by 0, right? So I cannot substitute. Let me check if I can apply the theorem. Can I apply the theorem? It looks like I can apply the theorem, right? X to the power n minus a to the power n. I have x. Here I have 1 and I have 1. I can write this as 1 cube. So x cube minus 1 cube. It's in this particular format. So I can write it as n into a to the power n minus 1. What do I have? What is the power? Power is 3. Here power is 3. And what is the number? 1. And decrement the power. So I'll get 3 into 1 square, which is 3. Now this particular problem, very straightforward problem here. Just substitute 1 for x, right? Substitute 1 here. So it will be a into 1, b into 1, again c into 1, b into 1. Finally, you'll get a plus b plus c. Here you'll get c plus b plus a. You can cancel it, is it not? Entire thing is a plus b plus c. I can cancel both numerator and denominator, right? So I'll be left with 1 because both are getting cancelled. Next one, 4x plus 3 by x minus 2. Let's substitute x as 4, right? Instead of x, I'll put 4. Instead of x, I put 4. So I'll get 19 by 2. Hey folks, I think you've forgotten to press a like. Do press a like if you found this helpful. Next problem. Here, x tends to half. If I put half, what's going to happen? Right? If I put half, check the denominator first, right? Check the denominator. Let's not spend time. Just check the denominator. I'll put half instead of x. Now 2 and 2 will get cancelled. I'll get 0. That's all. If the denominator becomes 0, then you have to stop it there. You'll have to look for another method. Let's see if you can apply the theorem. Now it looks similar. Somewhere it looks similar, like a theorem only, like this, right? It looks similar here. But you'll have to make small modifications. Always denominator is the clue. Now here you have 2x, which means numerator also should have 2x. Only then I can apply this. Because here if you notice, denominator is x, numerator also is x. Denominator has a, numerator also has a. Only power is there in the numerator in addition. So here you have 2x minus 1. So numerator also should have 2x. What do? I can write this 4x square as 2x the whole square. Right? What is 2x the whole square? 2x into 2x is 4x square. So instead of 4x square, I have written 2x the whole square. Now it's in this format. And instead of 1, I can write it as 1 square. Right? You can put any power to 1. It does not change. So now I can apply the theorem. So now what is n here? N is the power, which is 2. Right? Which is 2. And what is a? That is, what is the number here? 1. And decrement the power, 2 minus 1. The answer is 2. Now next one. Again here, by looking at, you can say you can apply the theorem. Right? But even then, let's substitute and see what will happen. If I substitute here, right? If I substitute 2 for x, it will become 0. Right? This is going to become 0. That's all. Stop it here. Now, this expression looks like I can apply the theorem, right? I can apply this theorem. Here it's reverse, right? This should be in the numerator. This should be the numerator. This should be in the denominator. Only then I can apply this theorem. But it is swapped, right? So what do? Simple. What I can do is, if this is n into a to the power n minus 1, I'll reverse this. What will happen if I reverse this? If I take reciprocal, this one will come to the denominator. It will become like this, right? I can say x minus a by x to the power n minus a to the power n is equal to 1 by n into a to the power n minus 1. Right? I can say this. I took the reciprocal on both the sides and I can say this. Same thing I can do here. I can do the same thing. So what I will do is, I'll put 1 by, it is 1 by, what is the power? 1 by 3. What is the number? It is 2. And reduce the power, 1 by 3 minus 1. So I'll get, I push this 3 on top. Right? I cannot have double division. So I have to take 3 on top. It will become reciprocal. It will become 3 by 1. So 3 will go on top here. 3 will go on top. And then I'll be left with this one. 1 by 3 minus 1 is 2 by 3 and 2. Now I can take, this is a negative power. Every time I have a negative power, you will have to make it positive. How you make it positive? By taking it to the numerator. So if I take this to the numerator, it will become 2 to the power 2 by 3. So minus will become plus. So this is the answer. This one. Now the problem, when you look at it, immediately it looks tricky, right? But it is simple. Now you know the theorem, right? Theorem is this one, like this, right? This is the theorem. Now what has happened here is, here you'll have to apply, what you can do is, you can divide numerator and denominator by x minus 1. That is what I want, right? I have x and 1 here. I want denominator with x and 1. So what I'll do, I'll divide numerator also by x minus 1, denominator also by x minus 1, both. So when I divide, the equation is not going to change, because ultimately you know that it will get cancelled, right? Actually this will get cancelled. So there is no harm in putting this x minus 1, right? But now for us to apply the theorem, we are dividing numerator and denominator by x minus 1. Now, so one problem is solved. I have x minus 1, I have x and 1 in the numerator and denominator. But I have plus sign here. What do I do? How do I remove this plus sign? For this theorem, I need minus sign, but I have plus sign. Simple, like earlier problem. Instead of plus 1, I can put it as minus 1, minus of minus 1, like this. I can put minus in between and say minus 1. And minus 1 to the power 9 is minus 1 itself, right? And minus will become plus 1. So I'm not modifying the expression. Expression is still the same. I'm just writing it in a different way. So now same thing we'll do in the denominator also, right? I have x to the power 5 plus 1. I will write plus 1 as minus of minus 1 to the power 5. Like this I'll write here, this one. Now I'll apply the theorem in the numerator separately, theorem in the denominator separately. So the power is 9 and number is minus 1, and decrement the power 9 minus 1. Similarly in the denominator also I'll apply the theorem. Power is 5. I have minus 1 and decrement the power 5 minus 1. So I'll get 9 by 5 as the answer. Now we'll go through limits for trigonometric expressions, right? So here you'll have to remember, whenever you see trigonometric expression, you'll have to remember a limits theorem. What is it? Limit x tends to 0, sin x by x is 1. And another one is tan x by x is also 1, right? This theorem, both this theorem, you have to remember whenever you see trigonometric expressions. Now I have sin ax by bx. Now here also, whatever x value I have, same x I should have in the denominator. Now for example, if I have 2x in the numerator, I should have 2x in the denominator also, like this. If I have 3x, I should have 3x. Then I can apply this theorem and call it 1, right? So I can have it like this, sin 10x by 10x as 1, 5x by sin 5x by 5x as 1. Now here what has happened? I have ax. You apply the theorem separately in the numerator. It's not necessary that you apply the theorem completely. You can apply the theorem here separately and here separately. So here I need ax in the denominator, right? I need ax. It should be in this form, right? But if I have to get ax in the denominator, then I should multiply. If I multiply and divide by ax and ax, then the equation will get balanced, right? I'm not changing anything, because ultimately we know that this will get cancelled and I'm left with sin ax. So I'm not modifying the expression. I'm just writing it in a different way so that I can apply the theorem. Now I'll not cancel it. What I will do is I'll take sin x by x separately. I'll apply the theorem because sin x by x is 1. So sin x by x is 1. This is equal to 1. And I'm left with ax. So put ax like that. And denominator bx, right? So x and x will get cancelled. So I'm left with a by b. Now next problem. Here I have sin x square. Right? Sin x square by x. What will I do? I will write this 2 times. Sin x square is nothing but, I can write it like this. Sin x into sin x. Sin x square is sin x into sin x by x. That's all. 2 times. So what I will do? I'll take ones like this. That is, I'll take this sin x by x. And this is 1. I'll apply the theorem. Sin x by x is 1. So I'll get this as 1. And then I'm left with sin x. So what I will do? I'll leave the sin x as it is. Instead of x, I'll put 0. Sin 0 is 0. So the answer becomes 0. The next problem. Find the value of limit sine 4x by sine 2x. Now, what will I do? Apply theorem in the numerator separately, denominator separately. I need 4x in the denominator like this, right? I need sine 4x by 4x so that I can apply the theorem, right? So what I'll do, I'll multiply and divide by 4x. Multiply and divide by 4x. Similarly, in the denominator, I'll multiply and divide by 2x. Now what will happen? For this portion, I can apply theorem, right? So this will be equal to 1. And I'm left with 4x by 2x. And then x and x will get cancelled. I'm left with 4 by 2, which is 2. Mostly all trigonometric expressions will be like this only, right? Let's look at another problem. Sine 3 theta by tan 2 theta. Again, don't overthink and think there is sine here, there is tan here, there is 4x here, there is 2x here. What do I do? No, don't worry about it. What you do, you multiply and divide numerator by 3 theta. And here also you multiply and divide denominator by 2 theta. That's all, like this. Now what will happen? This 3 theta by 3 theta will become 1, correct? And here, and tan 2 theta by 2 theta will become 1. And I will be left with 3 theta by 2 theta. Theta and theta will get cancelled. I am left with 3 by 2. Similar problem, right? Tan 4x by 3x. Again, don't think what will I do? This is different, this is different. No, what you do? Multiply and divide by 4x. In the numerator, you multiply and divide by 4x. In the denominator, multiply and divide by 3x. That's all. So this entire thing will become 1, right? This will become 1. This will become 1. I am left with 4x by 3x. X and x will get cancelled. So I will get 4 by 3. Now next one. Here this is slightly tricky, but just look at the method, right? Now here I have tan x in the denominator. If I divide the numerator by cos x, like this, x cos x by cos x, sin x by cos x, right? Now here cos x and cos x will get cancelled. I will be left with x. Then sin x by cos x is tan x. Now you see, numerator and denominator became same. I'll cancel it. So answer is 1. Now here are different kind of problems where to solve these problems you have to remember all these formulas, right? If you can manage to remember these formulas, then you can solve these problems, right? The other two kind of problems are easy. One is direct substitution and the trigonometric expressions is easy. But for these kind of problems, you need to know the formulas, right? This is the entire list of formulas, right? You can, there is a separate video on limits formulas, right? If you want to memorize, you can use that video where all the formulas are combined into one video. Now here, you have 1 plus 2 by n to the power n. You will have to remember this formula. If you notice, this is like 1 plus 1 by n to the power n. Instead of 1 by n, I have 2 by n. What do? I want to remove 2 because in this formula there is only 1 by n. I can't have 2 by n. So what do? I divide by 2. That's all. If I divide by 2, here also I divide by 2. So the equation gets balanced because in the numerator also I'm dividing by 2. In the denominator also I'm dividing by 2. So ultimately what will happen? Actually 2 and 2 will get cancelled. Right? Actually this 2 and this 2 will get cancelled, but I'm not going to cancel because I need this to apply this formula. So what I'll do, 2 by 2 and 2 by 2 will get cancelled, so I'll be left with 1. I'll be left with 1 and then this n by 2 will be there. Now what I will do, here in this formula, here I have n, here also there is n. So here if I have n by 2, here also I should have n by 2, but I have only n here. What I will do, again multiply and divide by 2. Right? Now I have n by 2, now I can apply this. What is it? E. So this entire thing will become E, right? This entire expression will become E. And I'll be left with this 2. So E square. That's all. Now this particular problem, for this you'll have to use this formula. 1 plus x to the power 1 by x is e to the power x. So instead of x I have 3x here. What will I do? That means here also I should get 3x. If I have 3x here also I should have 3x. This is the way we should solve it, right? Now that means I have to multiply and divide, right? If I multiply and divide by 3, then I will get 3x, right? So it will be like this. 1 plus 3x to the power 1 by 3x. And then I have this 3. Since I multiplied by 3, I have this 3. Put this 3 outside. Don't forget, put this 3 outside. So this entire thing is E. And then I have this 3. So it becomes E cube. Now next one. Let's look at this problem. I have n plus 3 by 3. First thing what I will do is I'll separate this out. N by 3 and 3 by 3 becomes 1. Now what do? Which formula to apply? There are 3 formulas. This is little confusing, right? You need to practice these kind of problems. Here I have n by 3. I can't put this 1 by n formula because it's n is on the numerator, here n is the denominator. I cannot apply this. Can I apply this? Here I have x and n, but there is no x at all here. No, I can't apply this. Can I apply this? I can, because instead of x, I have n by 3, right? I can say instead of x, I have n by 3, and instead of 1 by x, I have 2 by n. Now, 1 by x, actually it should be 1 by n by 3. Because I have n by 3, it should be 1 by n by 3. So, I'll shift 3 on top. So, what it will be? 3 by n. So, basically, if I have 3 by n here, I can directly apply this formula. So, but here I have 2 by n. I need 3 by n. Simple. Multiply and divide by 3. Multiply and divide by 3. So, now I'll get 3n here, right? This 2 you take it out. You take this 2 out like this. 1 plus n by 3. I can write it as 3 by n. I need this 3 by n, no? So, put 3 by n. And what are the additional things? I have to put 2 outside. Then I have this 3 also. This 3 and this 2 I have. 3 by n I have put here. This 3 and this n I have separated here. I'm left with 2 by 3. Put it out. Now this entire thing is equivalent to this. So I can put e here, right? Instead of this entire thing, I can put e to the power 2 by 3. That's what I've done. E to the power 2 by 3. Slightly tricky because all three formulas look similar here, right? But small differences are there. It's close to this one. Instead of x, I have n by 3. Instead of 1 by x, I have 2 by n. So I can multiply and divide by 3 and get it in this particular form. Slightly tricky, but you'll have to practice this problem. This is again straightforward. You'll have to directly apply the formula. This is the formula that you have to apply. E to the power x minus 1 by x is 1, right? Instead of e to the power x, I have minus 3x, right? These are easy. Since I have minus 3x, what I will do is, in denominator also, I need to get minus 3x. So what I'll do, I'll multiply and divide by minus 3. See, I multiply and divided by minus 3. So I'll get minus 3x here. What will happen to this minus 3? What will happen to this minus 3? I can push this on top, right? I have double division. So I'll push this on top. It will go to the numerator. Minus 3 will go to the numerator and minus 3x will be there in the denominator, right? So whenever you have double division, when you push, it will actually become a reciprocal. Minus 3x by minus 3 will become, it will become like this. When I push it on top, I'll get minus 3 in the numerator and minus 3x in the denominator. Yeah. Now, and to this entire portion, I'm applying the theorem, right? What is it equal to? 1. So, this entire portion will become 1. And then I'm left with minus 3. So, minus 3 into 1 is minus 3. Last problem. Here, you will have to remember this formula. A to the power x minus 1 by x is equal to log a. Instead of a, I have 2. 2 to the power x minus 1. And instead of x, I have 3x. What will I do here? I can take 3 outside, right? I just need x here. Because here also it's only x. Here I have x, but 3 is additional. Keep 3 outside like this, right? Then separate it out. So I'll get exactly in this form, right? So I'll put log a. What is a here? Instead of a, I have 2. So log 2 and 1 by 3. That's all. So with this, we've come to the end of this particular video. If you have found this video useful, do press a like and share it. Thank you.